Hi, Dr. Caps. Travis White-Velez here with this week's Advanced Concept Interactive Presentation. So for this week, I will be utilizing balloons to explain the geometry or show the geometry of the valence electron shells for atoms. The valence shell electron pair repulsion, or VESPER, is a model that accounts for electron pairs in the valence shells of an atom while repelling one another. The VESPER model shows you the electron domains and how they repel one another, and it pretty much states that they repel each other, or they're so far apart from each other that it minimizes their repulsive interactions. So essentially, an atom or an ion is set up so that the electrons will be spaced just far enough apart that they're not constantly fighting back and forth for room, because that would, change the shape of the atom or the ion that you were trying to show. And then molecular geometry is the arrangement of bonded atoms. And these definitions come from our book, Chemistry, the 5th edition, by Burridge, and it's published by McGraw-Hill. Stay tuned, and I will grab the balloons, and I will be back to show you a little bit more. And just before I do grab those balloons, just wanted to kind of explain some shapes. With two balloons, so this geometric formation is considered linear. So you have two atoms that are essentially, their electrons are repelling each other at opposite ends. And that again is linear. This shape is the triagonal plane. And it's important to note for this one, if there is one lone pair, then it produces a bent molecular geometry. And again, this just kind of demonstrates how they're not competing for space. They all have just enough room, but they hold their formation. This shape is called a tetrahedron. I believe I am saying it right. For this, it's important to note that you can have one lone pair, and that produces a triagonal pyramid molecular geometry. Or you can have two lone pairs, and that gives you a bent molecular geometry. And again, this is the tetrahedron. For this shape, we have a triagonal bipyramid. And for this, you can have one lone pair of electrons, which will kind of present as a seesaw-shaped molecular geometry. You can have two lone pairs, and that is a T-shaped molecular geometry. Or you can have three lone pairs, and that again gives you another linear presentation for its molecular geometry. And again, this one is the triagonal bipyramid. For this shape, this is the octahedron. And I will show you its shape first and then explain it. And for this shape, you can have one lone pair, and it creates a square kind of pyramid molecular geometry. You can have two lone pairs, and that gives you a square planar molecular geometry. You can have three lone pairs, which gives you a T-shaped molecular geometry, or you can have four lone pairs, which gives you again another linear presentation for its geometry. So it's important to note that the balloons in this presentation represent the electrons, and how all of them have just enough space to maintain the bond without fighting and changing the shape or the geometry of the atom that you were trying to present. This is often utilized in science just to give you a better visual than just drawing dots on a paper. This gives you more of a 3D visual, and some people find this a little bit easier to understand than, say, the Lewis dot structures, which is essentially where you write the element, and you put how many valence electrons are surrounding each portion of every element combined in that atom. Thank you for your time. I know this is a little bit confusing and I may not have done the best of explaining it, but I hope it does help you understand something if you're struggling with geometric shapes in chemistry. Again, thank you for your time. Stay safe and be well.